Hi everyone, here we are analyzing CSIR June 2011 Chemical Sciences. Just look at the given problem. 120 question. Papaverine on oxidation with potassium permanganate gives a ketone which on fusion with potassium hydroxide gives. So this is the structure of papaverine. Now just look at the mechanism. Here papaverine, whenever it is taken in cold KMnO4, then it produces a secondary alcohol. Whereas papaverine with hot KMnO4 oxidation, it produces ketone. Okay, just observe it. And in the next step, we have given it potassium hydroxide, and which is acting as nucleophile. Hydroxy group is going to attack on carbonyl carbon. Okay, just follow the arrows and cleavage of it takes place. And here we can get the final product. Just check the options. Okay, right. And next one. For the following allylic oxidation reaction, the appropriate statement among the choices given below is. Just observe here, suitable reagent is KMnO4 and major product is A, suitable reagent is KMnO4, major product is B, suitable reagent is selenium dioxide, major product is A, and suitable reagent is selenium dioxide and major product B. Okay, now just check the answer for that 138 question. So selenium dioxide, just follow the arrows. En type of reaction takes place followed by 2,3 sigmatropic rearrangement you can observe. Okay, just follow the arrows here, and after hydrolysis we can get allylic alcohol, and we can just rearranging this. So these two structures are same, and you can see that whenever hydroxy group, endo hydroxy group is there, repulsion will be raised by that that means here double bonded electrons and that hydroxy group. Okay, that's why here exo-hydroxy group will be most suitable one. Okay, and which is most stable among A and B structures. So A is a major product observed in this reaction, and the reagent is simply selenium dioxide. And next question, the intermediate A and major product B in the following conversion is. So 132 question here. Just observe, we need to find A and B here. So simply whenever NH2 functional group is reacting with NaNO2HCl, it produces N2 plus Cl minus, and just follow the arrows here. Elimination of carbon dioxide takes place. At the same time, stable eliminating group N2 also takes place, and that means it is cleared from it, and here is a formation of benzene intermediate. Okay, and we have given with the substrate, that means butene, 2-methyl 1,3 butene, right, butadiene, sorry, not butene, simply we can say butadiene, and we can rearrange that, transform into cis form, and here benzene and 1,3 butadiene, cis butadiene. Okay, so reacted with the considered mechanism, that means a 2 plus 4 addition takes place, and we can get the final product. Okay, right. And next question, the major product formed in the following reaction is the 133 question. Just observe here, we have given it palladium catalyst. So for load by lithium aluminum hydride, we need to find the correct product. So the first step is simply the copper is inserted onto that alkyne, and followed by reacting with palladium catalyst. So simply here coupling reaction takes place, and further on that ion reacting with the lithium aluminum hydride, the triple bond is reduced to double bond. And just look at here, so the two groups must be trans to each other to escape from the steric repulsions, and this will be the major product we can observe in this reaction. Okay, right, just check the mechanism well. Next one, in the following reaction sequence, the correct structure for the major products X and Y are. So just observe the substrates here, and we have given with base K2CO3, right? And in the first step, simply base can abstract more acidic proton, that means protons from that NO2 substrate. Okay, and that negative charge is going to attack on a beta carbon of alpha beta unsaturated substrate, and we can get this product. And further we have given with hydrogenation, that means a reduction with that H2, so NO2 is reduced to NH2, and then the lone pair of electrons on nitrogen of amine going to attack on carbonyl carbon. Okay, in that case lone pair of electrons goes here to eliminate hydroxy group, and we can get the final product. Here methyl and ethyl groups must be trans to each other. Okay, right, just observe it. And next question, the major product formed in the following reaction is. So here we have given with plus diethyl tartarate. So sharp plus epoxidation is given, and we need to look at the allylic double bond from the end of hydroxy group. Now we need to check the position of hydroxy group. Is it right side to the viewer or left side to the viewer? So you can see it is right side to the viewer. So whenever hydroxy group is right side to the viewer, then in that case here we need to look for that diethyl tartarate. Here we have given it plus diethyl tartarate. So in that case the epoxidation must be from the back side end onto that allylic double bond. So option A is the correct answer for given problem. Okay. And next question, the structures of major products X and Y in the following transformation is. Just observe, we have given with thermal conditions. Okay, right. And now, so just check the different options. And before going to explain that 136 question, just look at 137 here, because it will be very easy. So here pyrrole, simply Palnar synthesis, and 1,4-dihydropyridine with Hansch synthesis, isophenolene with Pictet Spengler reaction. Okay, right. Now just come to the 136 question, where so we can rearrange that diene, cyclic pentadiene, just like this. And here we have given with alpha beta unsaturated ketone, so 4 plus 2 concentrated mechanism. Here endo rule is, by just endo rule, this will be the major product we can observe as A, because here extra third interaction, pi interaction leads to stabilization of this product. That's why here, due to the involvement of endo rule, so this is the major product we can observe. So the keto group is endo position on that ring. Okay, a bridged substrate or bridged product. Now further photochemical conditions. So here we have alkene and ketone. So Paterno-Bucchi type of reaction takes place, and we can get the final product. Okay, just check the Paterno-Bucchi selection rules. Okay, in our courses. And next question, consider the following reaction. Just observe A, and which is producing B and C in presence of potassium hydroxide and ethanol in an experiment. 1.99 grams of bromide A on reaction with ethanolic potassium hydroxide gave 1.062 grams of mixture of olefins B and C. If the ratio of olefins B is C formed is 2:1, the yields of their formation respectively are. Now just look at 138. So here molecular weight of A 199 and the molecular weight of B 118. Now 199 molecular weight of A producing 118 grams of molecular weight of B. Okay, now in the problem we have given that 1.99 grams of A will give the product as 118 into 1.99 by 199. So that is equals to 1.18 grams of B product. Okay, but the yield is given as 1.062 grams. Thus the percentage yield must be equals to 1.062 by 1.18 into 100, that is 90%. And we have given in the problem as the ratio of B and C as 2:1. So the total is 90%. In that B must be 60% and C must be 30%. Okay, right. And next question, the Gauge interaction values of methyl bromine and bromine are 3.3, 0.8 and 3 kilojoules per mole respectively. Among the following, the most stable conformation of 2,3 dibromobutane is. So just observe interaction values. Methyl is highest 3.3 and methyl bromine is just 0.8 and bromine is 3. Okay, the least one for methyl bromine interactions. Okay, now just check the Gauge interactions. You can see in the first one methyl and bromine. That's why highly unstable. Here bromine, methyl. So it is also highly unstable. You can see bromine and bromine methyl and bromine methyl. Due to the presence of bromine, so it is also unstable, because highly unstable, because bromine interactions are giving 3 kilojoules of more extra energy to it. And if you look at here Gacha products of B, Newman projection B here, you can see bromine methyl and bromine methyl interactions only observed here, which are least, that means these interactions are giving least energy, that is 0.8 kilojoules per mole energy. That's why the most stable one is B. Okay, right. Next one, match the following. So just observe, the second one is the B structure is simply here double bond and direct attack. Okay, so not that structure, the structure is simply here, you can see double bond and these two carbons are directly connected. Okay, so that is the correct structure. And you can see here the axis is there, that means chiral axis for A. Okay, so this is chiral axis A matching with chiral axis, and B here double bond and this is directly connected, so chiral plane for it. Okay, B is connected with 3, and just look at C here, the due to the bulk rings present at the edges, you can see it is indicating helical chirality. Okay, helical chirality, right? So these are the matchings on it, and thank you very much.